Hello everyone, welcome back to the channel. I am Nikhil Kumar. In our previous video, we created container using Linux network namespaces and we saw something important. They had no IP, no connectivity and they could not talk to each other. But in real world, containers communicate, containers get IP and containers can access the internet. So the question is, how does that actually happen? What connects isolated container to the real network? So let's build that from the scratch. And for that, let's go back to the terminal and create our first container-like environment again. So for that, I am going to use the same unshare command. So unshare -net pid fork and bash. So let's press enter here. So now we are inside our first container. And to verify that, we can use echo $$. So we can see this is the process ID 1 that verifies that we are inside our container environment. Now it should show the same behavior as previous video. So if I see the network configuration of this particular container, so IP addr, and here we can see only loopback, and even the loopback is down by default because this is the fresh network stack. So let's bring this particular loopback interface up. So IP link set loop up. So we bring this up, and if we verify that, so now we have bring this particular loopback interface up. So this is basically a container but with no network connection. So right now this particular container is completely isolated and it's not having any connection with the host. So now we need to solve this problem. How does a container talk to the host? So for that we are going to create a virtual cable between host and the container. So let me do it very quickly and get back to the host. So here we need to go to the host. So here we need to create a virtual cable with two endpoints. So for that we can use a command that is IP link add veth1 -host. Type is veth, peer name that is veth1 -container. So this particular command creates a wire with two ends. The first end is veth1 -host and another end is the veth1 -container. So basically this creates a two interfaces like two ends of a wire. So let's press enter here. So if I run IP addr, so here we can see the two interfaces got created. So the first one is veth1 -container and second is the veth1 -host, and both are the two ends of the cable. But we need to move this particular interface to that particular container. So for that we need to get the process ID of the container. So we can use ps-ef and grep for unshare here, because we use unshare command to create a container, and if I hit enter here, so we can get the process ID of this particular container. So now let's move this particular interface or one end of the cable to the container. So we can use IP link set veth1 -cont and net ns and the process ID that is 3515. So basically this particular command sets this particular interface inside the network namespace of this particular process ID that is 3515. That is actually our container. So let's press enter here. So now we have moved this particular end inside the container and another end will remains on the host. And let's get back to the container, and if we run the same IP addr command again, so here we can see the another end of the cable or the interface has been moved inside the container now. So now we need to configure this particular interface. So for that we need to assign the IP address and bring this particular interface up. So for that we can use IP addr add 10.0.0.2/24 and the device that is veth1 -container. So the IP address has been assigned to this particular interface, and if I run IP addr, so the IP address has been assigned, but still it's down, so we need to bring this up. So for that we can use IP link set veth1 -cont and up. So now if I run IP addr, so now we have configured both the interfaces of the container, but we need to configure the another end of the cable that is at the host side. So let's get back to the host. So if I run addr, so this particular interface is down and it's not having any IP address as of now. So first of all we need to assign the IP address and we need to bring this particular interface up. So we can use the same command that is IP addr add 10.0.0.1/24 and the device name that is veth1 -host, and we need to bring this up. So IP link set veth1 -host and up. And if we see the network configuration, so now we have assigned the IP address and this particular interface is up. So that means both the end of the cable are connected. So now let's test the connectivity between the container and host. So first of all, we will do the ping from the host to the container. So for that, we can use a ping command. So ping -c3 10.0.0.2. So as we can see, it's able to connect to the container. That is the IP address of the container, that is 10.0.0.2. And if I try to connect from container to the host, so if I run ping -c3 10.0.0.1, so container is also able to connect with the host. Now it's clear, container and host is connected via virtual cable. And this is how container get network interfaces also. But there is a problem. This only connects with one container only. Because in real world scenario, we are not going to connect with one container. We are going to connect with the multiple containers. So how we can establish a connectivity between multiple containers? So now let's get back to the terminal and create another container. So now I'm going to create another container. So for that, I'm going to use the same unshare command. So unshare -net pid fork and bash. So now we're inside the second container, and if I run ipdaddr, so as we can see, this is a completely new network stack. So now we need to establish a connectivity from container 2 to the container 1. So for that as well, we need to create a virtual cable with two ends. So let's get back to the host, and I'm going to use the same command, that is ip link add, but this time I'm going to use a different ends of the cable. So here the veth2-host and the veth2-container. So it also creates a two interfaces internally, and if I run ipdaddr, we can see the two other interfaces has been created. Basically, these are the two other ends of the another cable. So basically, we are going to move this particular interface to the container 2, but for that we need to get the process ID of the container 2. So we can use the same command, that is ps-ef, and grep for unshare here. So this is our second container, and let's run the same command, that is ip link set veth2-container netns and 6987. So now we have moved that particular interface or the another end of the cable to the container 2. So if I run ipdaddr, so we can see it has been moved out from this particular host and moved inside the container. And if I run ipdaddr, we can see it has been moved inside this. So for this one as well, we need to assign the IP address first. So ipdaddr add 10.0.0.3/24 and dev, so veth2-cont. So now we have assigned the IP address to this particular interface, but we need to bring these two interfaces up. So we can use ip link set veth2-cont up. Similarly, we need to bring the loop back up. So we can use ip link set loop up. So now we have configured the network stack of the container 2, and if I run ipdaddr, so we can see it has an IP address and it's also up. So now the containers should talk to each other. So now let's test the connectivity between the containers. So we can use ping -c3 10.0.0.2. So as we can see, it's not working, because it's not having any connectivity to the container 1. And if I try to do the connection from container 1 to container 2, so if I run ping -c3 10.0.0.3, this is also not working and it fails. Why? Because both the containers are not on the same network. So to resolve this particular issue, we need to create something called bridge. So bridge will act as a virtual switch between the containers. So let me show you with the help of visual diagram. So here we have two containers, like container 1 and the container 2, and both are having interfaces, that is veth1-container and veth2-container. Similarly, we have created a virtual cable, that is veth1-host and veth2-host, which is being connected to each of the container. But this time it's not going to establish a connectivity using the veth-host or veth2-host. Instead of that, it will be using a bridge or the virtual switch, and we are going to move the another end of the cable, which is from the host side to the bridge, and bridge is the one who is responsible to establish a connectivity between the containers. So let's see in the action how it works. So let's get back to the terminal. So first of all, we need to go to the host and create a bridge. So for that we can use ip link add br0 type bridge. So here we are going to create a bridge named br0 and type is bridge. And if I hit enter, so here if I see ipdaddr, so another interface has been created with the name called br0 and it is having a bridge type. So first of all, we need to move this particular interfaces or the another end of the virtual cable to the bridge. So for that we can use ip link set veth1-host master, that is br0. Similarly for the vh2, that is vr0. And if I run ipaddr, so here we can see veth1-host is having a master that is vr0. Similarly for veth2-host, that is a master vr0. But we need to bring this particular interface up and assign an IP address as well. So for that, we are going to use this particular IP address which is been assigned to the veth1-host, because this particular interface will going to route the traffic via bridge, that is vr0. So let me delete this particular IP address from this interface and assign it to the vr0. So we can run ipADDR del and this particular IP address and from veth1-host. And I'm going to assign this to vr0. So vr0, and instead of delete, it's add. And we need to bring these two interfaces up. So we can run ip link set veth2-host, that is up, and ip link set vr0 up. So there is a typo, so let me update it. So now we have bring both the interfaces up and assign the IP address to the bridge as well. So if I verify that, so we can see veth2-host is up and having a master that is vr0. Similarly, veth1-host is also having a master vr0 and up. And bridge is also having an IP address and it also up. So this time container should talk to each other. So let's go back to the container one. And if I run the same command, so as we can see, it's working fine because of the bridge, because bridge is the one who is establishing a connectivity between the containers. And if I try to do the connectivity from the container to the container one, and if I run the same command here, so this one is also working fine. So we are able to establish a connectivity between the container using the virtual switch. And this bridge is exactly the same bridge Docker is creating at the backend with the name called Docker0. So if you notice, whenever you install a Docker or Podman, it creates a bridge called Docker0 at the backend. And it also creates a virtual keyword with two endpoints. So it follows the same step which we have done manually in this particular container, but Docker is doing automation for us. So we don't need to worry about the network connectivity between the different containers. But this time we did it manually and we understood how Docker works under the hood, how it creates a virtual cable and how it established a connectivity between the different containers. Now let's move to the final step. Let's give internet access to our containers. So first of all, we need to allow our Linux host to behave like a router. So for that, we need to run a sysctl command. So sysctl -w net.ipv4.ip_forward equal to 1. So here sysctl is used to modify the kernel parameters, and here I pass the parameter that is net.ipv4 IP forward. That means enable the packet forwarding. By default, Linux behaves like an endpoint, not a router. So with this, now host can forward packet between the interface. So if I hit enter, so it worked fine. And to verify that, we can use sysctl net.ipv4.ip_forward, and we got a result that is equal to 1. That confirms the kernel forwarding is enabled. Now we need to make sure container traffic can go to the internet and come back. So for that, we need to add a rule in the iptables. So for that, we can use iptables command. So iptables -t nat -a post routing and -s, and we need to provide a container network. So 10.0.0.0/24, and the interface of the Linux host, that is ENS4, and if we come here, that is ENS4, and at last -j and masquerade. So let me explain this command very quickly. So iptable manages the firewall rules, and -tnat means nat table, and here I specify the post routing. That means after routing decision it needs to take, that is -s, that is a traffic from the container network, and -o ENS4, that means going out from the internet interface. And at last I am passing the masquerade, that means replace source IP with the host IP. And this is exactly how your home routers also work. Let's press enter here. So the IP table has been modified, and to verify that, we can use iptables -t nat -l -n -v. And here we can see the masquerade rule here. So that means the NAT is configured. So now the one more important thing. NATing alone is not enough. Linux still blocks packet movement unless we allow forwarding. So for that as well, we need to enable the forwarding. So we can use iptables -a forward -i bridge and -o ENS4 and -j accept. So basically these commands allow traffic from container bridge to the outside. So let's press enter here, and we need to enable another rule that allows return traffic from internet back to the container. So for that, I can use the iptable command as well. So I will use this particular command that allows return traffic from the internet back to the container interface. So let's press enter here, and here if you see the state related and established, that means only valid traffic is allowed to the container. And if I verify this, iptables -l forward -n -v. So here we can see the forward rules. So the packet movement is now allowed. So now we have configured everything from the host side, but container needs to know where to send internet traffic. So for that we need to go back to the container and create a rule in the routing table. So for that we can use ip route add default via 10.0.0.1. So let me explain it very quickly. So here I am creating a route in the routing table, and here default means unknown destination like internet, and via 10.0.0.1 that means send it to the host bridge that will work like a gateway for us, and this is the IP address of our bridge only. So let's press enter here, and if I run IP route, so here we can see that default route has been added here. So container now knows for anything outside send traffic to the host, and this confirms container is using host as a gateway. So now let's test the internet access here. So for that we can use ping -c3 8.8.8. So as we can see, it's able to reach to the internet. So now let's connect everything we did. So container sends packet like from 10.0.0.2. It goes to the bridge, that is the 10.0.0.1, and host forwards packet to the ENS4, that is the main interface of the Linux host. And then net replaces the source IP to the host IP, and then it goes to the internet, and once the internet responds, it comes back to the host forwards back to the container. And this is how MASQUERADE handles source netting. But forward rules are required to allow traffic movement between the interfaces. Since we are using the Linux bridge, forwarding happened between the BR0 and the ENS4, not directly between the veth interfaces. Now let's connect everything together. Unshare creates the isolated container space, veth works like the virtual cable, bridge acts like a network switch, and net gives a container internet access. So when you run Docker, it's simply doing all of this automatically. Now you know how container gets IP, talk to each other, and reach the internet. No magic, just Linux doing the Linux things. In the previous video, we saw isolation, but in this one, we built connectivity using veth, bridges, NAT, and routing. But in real DevOps, building networking is easy, but debugging is the hardest part. Why pod-to-pod traffic is failing, why DNS is broken, and why can't container reach to the internet. And that's exactly we will solve in the next video. And trust me, that's where the real DevOps begin. If you found this helpful, hit like, share it with your friends, and subscribe for more content like this. Thanks for watching. I will see you in the next one.